Okay, so this is the first lesson in the trigonometry unit, and this is just a bit of a brush up or a revisor, I guess. Most of this stuff you should remember from earlier years of high school, particularly year 9. So the main thing we'll be dealing with today is right angle trigonometry. Later in this unit, we're going to be dealing with trigonometry where we don't have right angle triangles. So that's going to be sort of what we're building up to this unit. But we're going to start the first sort of 4 or 5 lessons are just going to be dealing with right angle triangles. So obviously, when we, in any right angle triangle, we need to sort of come up with a way of naming the sides. And the sides are always named with reference to our reference angle. So for this particular triangle we've got here, the reference angle is that angle I've just highlighted green. And we've got 3 sides. Obviously, the hypotenuse is always opposite the right angle. The reference angle has no bearing on where the hypotenuse is. It's just opposite the right angle. The adjacent side is the other side that touches the reference angle. So the reference angle is always going to touch the hypotenuse, and it'll touch one other side. That's the adjacent side. So it's I like to think of it as the person who lives next door to me is my next door neighbour. They live adjacent to me. That's the adjacent. The person who lives across the street from me, though, lives opposite me. So you can see that the opposite side does not touch the reference angle. It's on the other side of the triangle. Okay, so as long as we can remember that. And then once we know that, we remember these 3 trigonometric ratios. The sine is the opposite over the hypotenuse, the cos is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. And I'm pretty sure most of you would remember this by our good friend SOHCAHTOA. And remember, that just means that sine is the opposite over the hypotenuse. Cos or cosine is the adjacent over the hypotenuse, and tan or tangent is the opposite over the adjacent. Okay, so we just use that little I don't know what you'd call those, ask your English teacher, mnemonic I think is the word, to remember those basic identities. And if we understand and can use that and we can label our sides correctly, right angle trigonometry does not get too hard. And it was even going to start today even easier than that, because we're just going to start with learning how to plug it into our calculator again. So let's just use our calculator to find sine of 26 degrees. So to do that, we press the sine button, we press 26. I'd like you to get in the habit of closing the brackets. With this one, it wouldn't have mattered, you would have got the right answer, but sometimes when we get to more complex trig, if you don't close the brackets, you'll get the wrong answer. So if you just get in the habit of always closing the brackets, you won't get the wrong answer. So we'll go to say, it says 2 decimal places there, so that's going to be 0.44. Oop, wrong pen. Let's go back out of rainbow pen. So 0.44, cos 32.6. So very important that we understand whether or not it's a decimal or whether it's degrees and minutes, but in this case, it's a decimal. So 32.6, I close my brackets, hit equals, and I get 0.84 to 2 decimal places. And then finally, tan of 78 degrees, 32 minutes. That might be a little bit more confusing because we've got to remember that degrees, minutes, seconds button. So we just press 78, we press it once for degrees, 23, and you don't stop there, you've still got to press it again to say that's how many minutes it is. So it's 78 degrees, 23 minutes, that's what it should look like on your calculator. We press enter and we're going to get, what's that, 4.86 to 2 decimal places. Okay. And the next question, we're not going to calculate what the size of these angles are, we're just going to say what they are. So the 3 ratios, so we're going to have sine, cos, and tan of theta. And then we're going to have sine, cos, and tan of beta. That's just a funny looking B, it's the Greek symbol for beta. Okay, so what are they equal? Well, sine theta is the opposite over the hypotenuse. So the opposite side to theta is going to be that side, the adjacent side to theta is going to be over there, and for both, the hypotenuse is going to be on that side. So when we're talking about theta, the opposite side is 20, and the hypotenuse, no matter which angle we're talking about, is 25. For cos theta, we need the adjacent over the hypotenuse. The adjacent side is 15, and the hypotenuse is still 25. And for tan theta, that's the opposite over the adjacent. So the opposite side of theta is 20, and the adjacent side is 15. Now, things change because we're looking in relation to beta. In relation to beta, that's the opposite side, and that's the adjacent side. So our ratios are likely to change. So for beta, the opposite over the hypotenuse is going to be 15 over 25. For cos beta, the adjacent over the hypotenuse is going to be 20 over 25. And tan of beta is going to be the opposite over the adjacent. The opposite side to beta is that 15 metre long side, and the 20 metre long side at the bottom is the adjacent. Okay, so just make sure you understand that these things aren't fixed. It depends on which angle you're looking at it from what point of view. I think I usually draw a little picture of a sort of using theta as an eyeball, essentially. And there's my eyelashes, and I could even draw sort of a bit of a face on here and give the guy a bit of a nose. That's an ugly nose and a big mouth and some hair. So he's looking from this point of view. From his point of view, that's the opposite side, and this is the adjacent side. All right, it's a poor man being stabbed in the face with a triangle, but I'm sure there's worse things happening to people in the world. Rightio. So now that we know all that, we can use that to start calculating some distances. So in this particular case, this is our reference angle here. So if that's our reference angle, let's label our sides. Start by labeling our sides. Over here, that's the opposite side. Next to our angle, oh, sorry, wrong way to go. Next to our angle, but not the hypotenuse, is going to be the adjacent. And obviously the hypotenuse is going to be opposite the right angle. So in this particular case, we're not concerned about the hypotenuse. It's not going to help us any. We're concerned about the opposite and the adjacent, so that means we're going to be looking at tan. So tan of 45, actually write the formula first. So tan theta equals the opposite over the adjacent. So in this case, tan of 45 degrees, 39 minutes is going to be equal to x over 3.8. We multiply both sides by 3.8. If I multiply this by 3.8, then that's going to cancel out. I'm going to be just left with x. So I'm going to have to do the same to both sides if I want to do that. So I'm going to end up with x equals 3.8 times by tan 45 degrees 39 minutes. And now I just pick up my calculator and plug that all into there. So 3.8 times by 10, 45 degrees, 39 minutes, closing my brackets, and I get 3.8872. Did it ask to how many? To two decimal places. So 3.89, because 7 would round that up. And we're dealing with distances, so we better give our units as well. The answer is going to be in centimetres. Okay, so a little bit quicker this time. We've got the opposite side. We've got the hypotenuse there, the two we're interested in. I don't care about that adjacent side. There's no information of any value there. So the opposite over the hypotenuse, that's going to be sine. So sine theta equals the opposite over the hypotenuse. So let's substitute in what we know. Sine of 37 degrees, 22 minutes equals x over 2.8. We multiply both sides by 2.8. We're going to end up with 2.8 times by sine 37 degrees, 22 minutes equals x. So we plug that all into our calculator and we get 2.8 times by sine 37 degrees, 22 minutes. And to two decimal places, that's going to be 1.69. The 9's going to round up, so we're going to actually end up with 1.70. And that's in metres in this particular case. Okay, so moving right along, we're now going to deal with when the pronumeral is in the denominator. Actually, what I'm going to do there is I'm going to pause the video there, just because I want to have enough time to go through all three examples. If we're returning to trigonometry, I think we should take our time. And I have a 15-minute limit on my videos on this program. So I'll pause there, and I'll do a second video where we go through examples 4 and 5, and that'll be that.